What's up, guys? We're talking about solving equations with variables on both sides. Remember, we've done a lot of warm-ups based on this. So this is kind of like the formal lesson on it. So yeah, our objective, solving equations with variables on both sides of the equation. Some vocab: variable, coefficient, inverse operations. Variable is just is this fading here? Variable is just a letter that replaces a number. And so basically you isolate the variable, you find the variable in an equation. Coefficient is just the number in front of a variable. And then inverse operation is how you basically solve these operations, right? We talk about the opposites of these operations, like addition and subtraction are opposites, and then multiplication or divisions. Multiplication and division are opposites as well. So in this first situation here, we have Jose and Solomon doing a charity car wash. They collected an equal amount of money during a car wash. They collected both cash and checks. If each check was written for the same amount, X, that's our variable. Oh, look at that variable. What is the total amount of money collected by both boys? Please show your work and write your answer in the form of a complete sentence. That's what that is. PSY, please show your work, etc. Okay. All right. So we got the boys right here. This is Jose, collected $15 in cash and 14 checks. And Solomon, oh man, I need to tighten this thing up here. And then Solomon collected $50 in cash and 7 checks, right? So we're going to define our variable first. So X is, each check was written for the same amount, so the amount on each check, right? So you kind of, when you have a word problem like this, you want to define the variable you're using and what it means, okay? Now, what is important to know is that they collected an equal amount of money. So we've got an equal sign. That's what makes this an equation, right? So Jose collected $15 in cash and 14 checks, right? Now, we don't know how much each check is worth. That's what we're trying to find, right? We're trying to find that variable. So we're going to say 14 times X and then plus $15. That represents Jose's side. And then Solomon's side is, similar but different numbers, 7X and then plus $50 in cash. Okay, so really similar to the warm-ups we did last week. We want to get this x over here, right? So I'm going to do an inverse operation. This is a positive 7x. I'm going to subtract 7x. That'll cancel it out to 0 on this side, right? And I bring it to this side and I match it up with the 14 here, not the 15. Okay, and then I subtract it to get 7x plus 15. I bring down that 15. And the 50, because I haven't done anything with it yet. If you'd like to draw that line, draw the line. And I take this 15 and bring it to the other side. Since it's adding, I do the opposite, which is subtraction. I end up with 7x equals 50 minus 15 is 35. Okay, and then now I have the variable right here, and I have the number in front of the variable. This is called the coefficient. So the coefficient of this equation is 7. Golly, this thing, I need to tighten this up if I can. There we go, maybe that'll work. So the 7 is the coefficient in front of the variable, okay? That's just the number in front of it. This is multiplication right here. When you have a 7 next to an x, I'm going to divide by 7 on both sides because that's the inverse or opposite of multiplication. And 35 divided by 7 is 5. So x equals 5. So we'll say each check was written for $5. Okay, so the total amount of money, once we have that 5, we'll basically take this 5 and plug it in to kind of double check our work. We can do it on either side of the equation. So we'll just do it on Solomon's side. So it's 7 times 5 plus 50. 7 times 5 is 35, plus 50 is $85, right? And if we do it on the other side, 14 times 5, right, plus 15. 14 times 5, let's see, is 70, plus 15 is 85. So 85 equals 85, right? So each check was written for $5, so they each collected 85. So that's kind of our summary right there. Okay. Now we have a linear equation with fractional coefficients. So we have these fractions out here, 3.5 and 3 1/4. Let's see. So probably the easiest way is to get these so they have common denominators. So if I have a denominator of 4 here, I can actually multiply the top and the bottom by 2 to get to that. So if I do that times 2 here times 2, this becomes 3 2/4. X plus 8 equals 3 1/4. x plus 10. There's a couple ways to deal with this. Like we could even convert these to fractions if we wanted to. I'm just going to, convert them to decimals if we wanted to. I'm going to subtract just the fraction right here. Okay. So that cancels out to 0. The 3's cancel out. Now we have 2 quarters minus 1 quarter is 1 quarter. So I've got 1 quarter x plus 8 equals 10. Okay. I subtract 8. I get a quarter x equals 2. A couple ways to think about this, right? Quarter of what number is 2? You could also think about this as x over 4 equals 2. So this is division right here. So we use the inverse operation of multiplication to get to x equals 8. Okay. Yeah, you could convert this rather than doing common denominators. You could do something like you could do 3.5 and 3.25, which would give you the same thing because you subtract that to get to 0.25. You could also convert this to improper fractions. So that would be 2 times 3 is 6 plus 1 is 7 halves. And then this would be 13 fourths, but then you'd also have to figure out common denominators. So a couple ways to solve that. But yeah. All right, so how much is each blue triangle worth right here? I have 3 triangles on the left, and I have 1 triangle on the right. So I'm going to say 3 triangles plus 2 equals 1 triangle plus 16. So I would subtract that 1 triangle. And if I have 3 triangles minus 1 triangle, that gives me 2 triangles. Plus 2 equals 16. I do the inverse or opposite of that addition right here. Cancel it out. I get 2 triangles equals 8. Now at this point, I'm going to break it down. I'm just going to say I have literally 2 triangles right here, right? If I'm adding them together, right, that just gives me 4 and 4. So 1 triangle is 4. Oh, it's all good. You can close that if you want to. That's fine. That doesn't matter. Okay. So we're talking about decimal coefficients here. It's like it's Romeo and Scarlet. Solve an equation with decimal coefficient. Romeo earns a salary weekly salary of $9.25 and a 5% commission on his total checks, total sales. So basically, if he sells $100, then he makes $5 on that commission. Is this not focusing? Come on. And then similarly, Scarlet makes $12.50 a week with the 3% commission. What amount of sales? X. So we'll say X equals number. We'll say amount of sales rather than number, because that's a weird way to say it. Amount of sales will result of each of them earning the same amount. So that's the key, right? Since it's the same amount, we can make this into an equation. I'm going to have Romeo on the left, Scarlet on the right. So this 5%, I'm going to convert that to a decimal. So basically 5% just move the decimal over 2, so we get 0.05 x times that amount of sales plus 925 is equal to 0.03 x plus 1250. I'm going to subtract this 0.03x over here because it's positive. So I take it away from this side. I'm going to combine like terms. I do not combine it with that 925 because this doesn't have an x. So this is 0.02 plus 925 equals 1250. Okay, I subtract that 925 over here. Cancels, and I'm just going to pull out a calculator for the next part of it. 1250 minus 925. 1250 minus 925 gets us to 325. So this should be an x. So 0.02x equals 325. And then I'm going to divide by 0.02 on both sides. And again, I'm just going to go to a calculator, right? Use the tools that you have as appropriate. So x is going to be whatever that 325 divided by 0.02 is. Nope, my bad. 325 divided by 0.02. If I type it into the calculator, 0.02. There we go. 16,250. So that's the amount of sales that they would need to have the same amount of salary each week, or take-home pay, I suppose. So we'll say, I'll put it in the middle because I'm running around, 16,250 is the amount of sales they would need to have the same paycheck. Ta-da. And we're kind of running out of room on that one. I didn't give you guys enough room on this. All right, solve equations with negative coefficients. So Julian has 410 in a personal bank account and then withdraws 19 per week. Jimena has 10 in a personal bank account and then deposits 31 earned from babysitting each week. After how many weeks will they have the same amount of money in the bank? We'll say, that's what it's asking, how many weeks. We'll say X equals number of weeks. You can call it W or whatever, it really doesn't matter. So Julian starts with 410. And he's withdrawing, which means he's taking that out. So it's 19 per week. So that per week matches with that X, right? So it's 19X. But since he's withdrawing, he's taking it out, right? And he starts with that 410, right? You could also write this as 410 minus 19X. Kind of really either way. But if we write it like this, then this lines it more up with the warm-ups that we did last week. So Jimena has 10 and then deposits 31 earned from babysitting each week, right? So 31 earned from babysitting each week, that matches up with the X, but she's depositing it, so it's positive, and she starts with 10, so that's positive as well, okay? So what we're gonna do is we're gonna take this 31X and we're gonna subtract it over here. Right, so this does say negative coefficients, right? So we have this negative coefficient right here, the number in front of the variable. That cancels. We subtract here. Negative 19 minus 31 is negative 50x plus 410 equals 10. We're going to subtract 10 here. Oh, was this right? Yeah, this is right. Boom, sorry. So it gets us to negative 60x. It's 410, my bad. That's what I'm screwing up. Okay, cool, there you go, that cancels out. And then this gets us to negative 400, okay? And since we have negatives on both sides, I can see that those negatives are gonna cancel when I do my division here. And it should be 50, not 60, my bad. Sorry, so 400 divided by 50 is 8. Right? Because those cancel out, those zeros, so then it's 40 divided by 5, basically, or negative 40 divided by negative 5 is a positive 8. So after how many weeks will they have the same amount? So we'd say after 8 weeks, they'll have the same amount. Okay. A different way to do this, right? This is called the hanger method, right? And the idea is that you balance the hanger so it doesn't like tilt to one side. So think about a clothes hanger with things hanging from it. Gosh, if I could focus this, that'd be great. Okay. All right, so we know that the purple diamond is worth 2, right? This is a similar concept to the using the shapes right here, the triangles, right? It's just kind of a different way to like visualize this. So I've got, this is basically my variable right here. You could think of this as an X, but in this case, we'll just use a shape in its place. So I got 1, 2, 3, 4, 5. Well, let's use the hanger, right? So the idea here is that we're gonna cancel out, right? So I've got 1, 2, 3, and I go 1, 2, 3 right there, okay? And I have 2 here. It's going to cancel out 2 right there, okay? So what I have left after I've canceled things out on the left and the right to balance things out is I have these 2 boxes, and I have 1, 2, 3, 4 of these, but I know that each of these is worth 2. So it's 1, 2, 3, 4 times 2 is 8. So I have 2 times this, right? To balance that equation, I'm going to divide by 2, right? And I get my box is worth 4. Okay, so basically the hanger method just kind of allows me to simplify ahead of time before like actually doing the math here, right? But I could also think about it as being like I have 1, 2 right here, and I know this is 2, 2, 2, 2, right? And so this, yeah, anyway. So that's 8 right there. So that's two box per 8 of these, right? So we get boxes 4. Okay. And now, just because you're going to see similar thing on the test right here. Got some analysis, right? I'm saying that the square root of 11 is 5.5 because 5.5 times 2 is 11. So it goes between 5 and 6 right here on the number line, right? However, we know that that's not how we do square roots. We don't divide them by 2. We figure out what number multiplied together gets us to 11, right? We know that 11 is in between square root of 9 and 16, which means it's in between 3 and 4. It's 2 away from that 9, and it's 5 away from that 16. So it's closer to 3. It's going to be about 3.2. So we know that it's going to be right there, okay? So why am I wrong? Well, I'll say I'm wrong, or you would say Mr. Richard, right? I'm wrong because you don't divide square roots by 2. Or by 2, either way. You figure out which number multiplied by itself gets you to the square root. And that's that. There you go. Enjoy.